Cool! Now that you know how to create schema messages with Singer, let us continue with the record and state messages so that we can create a full ingestion pipeline with the Singer library. Here are the user records we saw earlier. To convert one such user into a Singer record message, we'd call the writeRecord function, like this. The stream name would need to match the stream you specified earlier in a schema message. Otherwise, these records are ignored. This would be almost equivalent to nesting the actual record dictionary in another dictionary that has two more keys, being the type and the stream. That can be done elegantly with the unpacking operator, which are these two asterisks here preceding the fixed dict. That unpacks a dictionary in another one and can be used in function calls as well. Really useful. Now, I did say almost equivalent. The truth is that Singer does a few more transformations to make better JSON, but the details are not that important. Simply use the functionality that is offered to you to benefit most. When you would combine the write schema and writeRecord functions, you would have a Python module that prints JSON objects to standard out. If you also have a Singer target that can parse these messages, then you have a full ingestion pipeline. In this example, we used writeRecords instead of writeRecord. It can simply deal with many records compared to the single one of writeRecord. We're introducing the target CSV module, which is available on the Python package index. Its goal is to create CSV files from the JSON lines. The CSV file will be made in the same directory where you run this command, unless you configure it otherwise by providing a configuration file. By the way, nothing prevents you from running a tab by parsing the code with a Python interpreter like this. But you'll typically find tabs and targets properly packaged, so you could call them directly, like this. You might wonder why we'd go through all this trouble just to produce a CSV file from a few simple records. After all, Python CSV module provides this functionality out of the box. The answer is modularity. Each tab or target is designed to do one thing very well. They are easily configured through config files. By working with a standardized intermediate format, you could easily swap out the target CSV for target Google Sheets or target PostgreSQL, for example, which write their output to whole different systems. This means you don't need to write a lot of code. Just pick the tabs and targets that match with your intended source and destination, and voila, you're ready. We haven't discussed Singer's state messages yet. They are typically used to keep track of state, which is the way something is at some moment in time. That something is typically some form of memory of the process. Imagine, for example, that you must extract only new records from this database daily at noon local time. The easiest way to do so is to keep track of the highest encountered, last updated on value and emit that as a state message at the end of a successful run of your tab. Then you can reuse the same message at a later time to extract only those records that were updated after this old state. You emit these state messages using the writeState function. The only required attribute is the value, which can be any JSON serializable object. The value field is free-form and only for use by the same tab. Let's write our own custom tab for ingesting data from a